Hello, ladies, gentlemen, and in between, and welcome back to another episode of Maths with Hamblin with your beautiful host, Hamblin. And today, my boys, we're going to look at some hard quadratic questions just to finish off our study of solving quadratics, and then we can move on to graphing and solving some quadratic inequalities, and then we'll be done with quadratics. Now, isn't that wonderful? And then we can move on to cubics. So anyway, without further ado, let's get into the first one. Okay, so my boys, this first one we're going to do is just we're going to start off with an easy one as a nice warm-up to the next two big scary ones. So if we look at the question here, we'll be giving a function, and it's this nice quadratic polynomial, and the first part is how many solutions are there to the equation f of x equals 0. So basically we're trying to solve 5x squared plus 3x minus 8 equals 0, or you could think of it as we're finding the roots of f of x, and we're being asked how many solutions are there, and we know that we can use the discriminant of the quadratic to find how many solutions there are. Recall, the discriminant is equal to b squared minus 4ac, where this is b, this is a, and this is c. And we can check the value of this number to see exactly how many roots of the quadratic there are. Remembering, if it's positive, there's 2 roots, if there's 0, there's 1, and if it's negative, there's none. So let's chuck this in. So b squared is 3 minus 4 times 5 times negative 8. Okay, we're going to get 9. And then these two negatives become a positive, and then we've got 4 times 5 times 8, but I'm not actually going to bother calculating the value of this. All we need to see is that it's obviously going to be greater than 0, so that implies there's 2 roots to the quadratic. So if I just rub this bit out quickly, because the discriminant was positive, there are 2 roots to the quadratic, or there are 2 solutions, if we're going to answer the question properly. Right, and the next part is to just solve f of x equals 0, and I'm going to do this by factoring, just as a little revision on how to factor quadratics where a is not equal to 1. Okay, right, so we're going to set this up. We're going to say, okay, 5x, x, and we have 2 mystery numbers here we're going to try and solve for. 5x times something equals something, x times something equals something. We want those 2 things at the end to add to positive 3x. And we want these 2 mystery numbers to multiply to negative 8. So if we start thinking about this, we could have negative 4 and 2. Well, that doesn't look like that's going to work. Okay, what about positive 8 and 1, you might say? And that does in fact work. If we have a positive 8 here and a negative 1 here, we're going to get 8x minus 5x, which is 3x, which is brilliant. So we can have 8, negative 1, and now we take the diagonals, and then we can rewrite this function as 5x minus 1 times x plus 8. And then if we set that equal to 0, and now we can just do the basic factorization, we think, okay, either this or this is equal to 0. So if this is equal to 0, then x equals 1/5. That's our first solution, or root of the function, you could also say. And our second solution will come from this bracket. If this is equal to 0, then x equals negative 8. So boom, there are our 2 solutions to the quadratic, nice and easy. Okay, so my boys, this next one, if we take a look, that looks pretty monstrous. We haven't even got a quadratic up there. Like, that's not a quadratic, it's got x to the 4th, for Christ's sake. It's a quartic polynomial. Well, not to worry. Just wait a sec, we'll see. And the question is to find all the roots of f of x. So in other words, we're going to try and solve this equation when it equals 0 to find all the numbers that you can chuck into f of x, and then output 0. So if we do that, we're going to get 2x to the 4th plus 3x cubed minus 10x squared equals 0. And oh my god, how are we going to do that? Well, don't worry, this is secretly a quadratic in disguise, my friends, because look what happens. If we factor out an x squared here, we can factor out an x squared. See, it's common in each term. So if we factor out x squared, then okay, we're going to factor out 2 lots of x from this power here, so we're going to be left with 2x squared. And then similarly here, we're going to be left with 3x, and then we're going to be left with minus 10. And if you don't believe me, just expand that out and you'll get back to this. So this is exactly the same as that, but look what's popped out, a quadratic, and we can solve quadratics. We can get the 2 roots of this one, and we can solve from this factor here to get all the roots of f of x. So consider first, okay, we've got the product of 2 things equals 0. Standard logic applies, either this or this equals 0. This looks pretty easy. So either x squared equals 0 or 2x squared plus 3x minus 10 equals 0. Okay, so from this one, you can take the square root on both sides and you'll get plus or minus 0, but positive 0 and negative 0 are the exact same thing. So the first one is just x equals 0, which makes sense, right? Because if you plug x equals 0 into this thing, all the terms will get killed by 0 and you're just left with 0. So it makes sense that that's a root. And now from this one, well, we could try and factor, but you know, we're going to try and use every method to our disposal in this video. So I'm going to use the quadratic formula. So our solutions are x equals negative b plus or minus, to get both solutions, b squared 9 minus 4 times 2 times negative 10 all over 2a, which is 4. And then we can simplify that a bit. That's negative 3 plus or minus, okay. Negative and negative cancel out, so that's 9 plus 4 times 2 times 10, so it's 9 plus 80, so it's 89. So root 89 over 4, and boom. We can't get any more solutions, so these are all the three roots of f of x. They're x equals 0, x equals negative 3 plus root 89 divided by 4, and x equals negative 3 minus root 89 over 4. Those are all the three roots of that quadratic, and that is something you might need to use eventually. Always watch out for when you can factor out something. This equation looks kind of sus, right? Always look for when you can do something crazy like that. And we're also going to get an example of that in the next one. Let's do it, shall we? Okay, so my boys, this last one, this also, just like the last example, looks pretty flipping hard, right? I mean, you've got another x to the fourth, another x squared. I mean, this is not a quadratic. How are we going to solve this? But don't worry, this is a quadratic in disguise. And bear with me for a moment. The question is to solve f of x equals 2. So we're going to set up the equation f of x, and we're going to do this, set it equal to 2, and then see if we can get anywhere. So take x to the fourth plus 2x squared minus 1 equals 2. We can bring that 2 over to the other side, and we get minus 3 equals 0. Okay, so now we've got this equation here. How can we possibly solve that? Well, if you're a bit clever, if you use your brain a bit, you might notice this funny thing. X to the fourth is just x squared, and then you square that whole thing. Remember, you can multiply the powers here, exponent rules. And then we've got plus 2x squared minus 3. Look at that. We've got a thing squared plus blah 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 the thing minus a number. That's a quadratic. That's a quadratic in disguise, but it's a quadratic with x squared as your variable. It's crazy. So we can just carefully apply the quadratic formula and we can get the solutions to this quadratic equation. So let's do that, shall we? Remembering that if we use the quadratic formula, we're going to get this thing, not just x, we'll get x squared. We're going to get x squared equals, okay, well, negative 2 plus or minus the square root of 2 squared, which is 4, minus 4 times 1 times minus 3. Right, okay, so let's use our brains a sec. Right, so minus and minus, that's a positive. 4 times 3 is 12, 4 plus 12 is 16, and the square root of 16 is 4. So we can just get rid of all of this terrible stuff and just replace it with a plus minus 4 over 2. And now this is kind of cringe. We've got x squared equals this thing with a plus or minus, but not to worry, we can just write out each solution individually. So let's do that. We've got x squared either equals negative 2 plus 4 over 2, or we've got x squared equals negative 2 minus 4 over 2. Negative 2 plus 4 over 2, that's just 2 over 2. That's just 1. Oh, what a lovely number. Oh. So x squared equals 1 is one of our solutions. And x squared equals negative 2 minus 4 over 2. Negative 2 minus 4 is negative 6, divided by 2 is negative 3. And so we've got, or x squared equals minus 3. Okay, right, so these are our two equations now that will give us the roots. First of all, notice x squared equals negative 3. If we try and solve x and take the square root, we're going to be square rooting a negative number, which is no. So put a big cross through that. We're not going to get any solutions from that one. But x squared equals 1, we can sensibly take the square root of that. We can take the square root and we get positive or negative 1 as the answers. So x equals 1 or x equals negative 1. There we go. We've solved it with a little bit of a clever trick here. This is a very useful trick, by the way. Keep this in mind. And my boys, that will conclude this episode today. Just a little closing off on our study of solving quadratics, and then next time we'll get into graphing quadratics and solving quadratic inequalities. So guys, thanks for watching. Let me know if you found this helpful, and I'll see you in the next one.